Good morning, friends and teachers. I am Shashank, studying first year in chemistry in JCS College of Arts, Commerce and Science, Ooty Road, Mysore. Today, my topic is about supercritical fluid extraction, its principal properties of supercritical fluids, advantages of supercritical fluid extractions, and offline and online extraction in supercritical fluid extraction. Today, let us learn about supercritical fluid extraction. Before moving straight into the topic of supercritical fluid extraction, first let us learn about what are supercritical fluids. So, supercritical fluids are substance which is held at or above the critical pressure and temperatures, which means the supercritical fluids are behaves more like a gas and liquid together, all together, combined together. It has the properties both such as gas and liquid properties. So at this stage, it causes the gas and liquid states become indistinguishable from one another. Virtually. That means the supercritical fluid in its appearance, when we see the supercritical fluid through our eyes, it uh, appears as the same. We cannot distinguish between it as a gas or it as a liquid. It has the convergence properties of both gas and liquid combined. So as you can see here, the supercritical fluid, carbon dioxide is presented here. The supercritical fluid, carbon dioxide in the gaseous form and liquid form are present. As we increase the temperature and pressure to the supercritical fluid, the temperature and pressure, it goes on miscible and it mixes together to form a single immiscible supercritical fluids which is indistinguishable virtually. So the supercritical fluids fill the empty container like a gas, but the molecules in supercritical fluids are closely arranged, much like a liquid, which means the supercritical fluids are movable like a gas, but the molecules on the supercritical fluids are much closely arranged like a liquid rather than the gas. It behaves as a gas, but it's not a gas. It has some properties like a liquid, but it's not a liquid. It is exactly in between the gas and a liquid. So the closer to the critical point, small changes in pressure and temperature results in the large changes in properties like density and viscosity and allowing many such properties to be tuned. This is one of the advantages and main properties of supercritical fluids, that we can tune the supercritical fluids viscosity and density according to our wish to perform the supercritical fluid extraction. So by altering the temperature or the pressure, we can increase or decrease its density or viscosity according to our wish. So let us compare its properties with gas and liquid. So as you can see here in the table, the supercritical fluid has the density of 0.2 to 0.5. When we see the density of a gas, it has 0.6 to 2 into 10 raised to the power of minus 3 gram per cm cube. When we see the density of liquid, it comes between 0.6 to 0.2. So the density of supercritical fluid exactly lies in between the gas and liquid. It is exactly in between the gas and liquid, which means that it has both properties of a gas and liquid. When you come to the diffusion coefficient of a supercritical fluid, the gas has 1 to 4 or 10 raised to the power of minus 1, and if you come to supercritical fluid, it has 10 raised to the power of minus 3 to 10 raised to the power of minus 4. If you come to liquid, it has 0.2 to 2, 10 raised to the power of minus 5. So the diffusion coefficient, as you can see here, is much shifted towards liquid. So which explains that the molecules arranged in the supercritical fluid are much more like a liquid. The molecules densely arranged, so it helps to diffuse in the way the liquid does. So the diffusion coefficient is much more shifted towards liquid, which explains the molecular arrangement in supercritical fluids, which is similar to that of liquid. When you come to the viscosity of the supercritical fluid, comes to 1 to 3 of 10 raised to the power of minus 4. If you see the gas, it has a viscosity around 1 to 3 10 raised to the power of minus 4. If you see the liquid viscosity is, ranges from 0.2 to 3 10 raised to the power of minus 2. So you can clearly see that the viscosity or the thickness of the supercritical fluids are much more shifted towards the gases. So it moves and behaves like much more like a gas. So and if you see the diffusion coefficient, it has the molecular arrangement much more shifted towards the liquid. So by seeing this tabular column, we can understand the properties of supercritical fluids, which is exactly in between the gas and liquid, which has both the properties of gas and liquid when it comes to diffusion and viscosities. So, as I explained here in the tabular column, as I said earlier, it diffuses through the solid like a gas and dissolves the substance like a liquid. It moves like a gas through the solids, any kind of a solid, but it also has the properties of liquid, so it dissolves the substance like a liquid. It is one of the major property advantages of supercritical fluids, and there are many examples to take in supercritical fluid, but among which the carbon dioxide as a supercritical fluid are widely used today, and it has many more applications in the field of supercritical fluid extractions. So we can choose carbon dioxide as the best example of supercritical fluid. So let us see some principles of supercritical fluids. The principle of supercritical fluid extractions are similar to that of high performance liquid chromatography or HPLC. However, supercritical fluid extraction used to replace the liquid mobile phase. That means to say that in high performance liquid chromatography, liquid is used as mobile phase. But in supercritical fluid extraction, supercritical fluid, to be more precise, supercritical carbon dioxide is widely used as a mobile phase in supercritical fluid extractions. So when you move on to the entire chromatography flow path must be pressurized, and because we know that the supercritical phase represents a state in which liquid and gas properties converge. So in order to ideal performance of a supercritical fluid, we have to give it necessary pressure in the column to performance of a supercritical fluid. So the entire column which are used in supercritical fluid extraction must be pressurized to the ideal behavior and ideal yield using supercritical fluid extraction method to get ideal yield using supercritical fluid extraction. So the supercritical fluid phase represents a state in which a liquid and gas properties converge. So it is also known as convergence chromatography, which explains, as I said earlier, the properties of gas and liquid converge. It has both the properties of gas and liquid. So the supercritical fluid extraction is also known as convergence chromatography. So let us move on to the advantages of supercritical fluid extraction. One of the advantages of the supercritical fluid extraction is that it has lower densities and viscosities than liquid. This results the larger diffusion coefficient for the solutes in supercritical fluid than liquid chromatography. It has a the supercritical fluids has a lower density and viscosity than liquids, which makes it more helpful than to move. The movement of the supercritical fluid when compared to any liquid is much more easier when compared to liquid because the molecules are arranged much freely, and it has since it has the property as the gas, it moves like a gas, so the movement of the supercritical fluid are much more restrictionless when compared to any movement of a liquid. So it has the larger diffusion coefficient than in the liquid chromatography, and then better efficiency and higher optimum linear velocities can be achieved in supercritical fluid extraction than in liquid chromatography. And then when come to the supercritical fluid extraction, these have the density is higher than the gas. The supercritical fluid density is much denser than the gas, which means the molecules are much closely arranged when compared to the gas. So the mobile phase has the greater chance of interacting with the solute than that of gas molecule. The mobile phase use the supercritical fluid when we use as a mobile phase and compared to the any gas which are used in gas chromatography, the supercritical fluid molecules are much closely arranged, so it has the greater chance or greater probability to interact with any solute molecules than when compared to gas. So it is one of the most important advantages when it comes to supercritical fluids. So then when we move on to this, mobile phase play an important role in determining the retention of solutes. So the supercritical fluids has the advantages of wide range of selectivity to increase or to modify the retention times. We can either increase the time as we do in gas chromatography, or we can increase the retention time by choosing the method which are employed in liquid chromatography. To increase the retention time in gas chromatography, we usually increase the column length by adding a different kind of column to it. So this method can also be employed in supercritical fluid extraction to increase the retention time. But we can also use by changing the mobile phase strength as in liquid chromatography. We can employ any of the method we want or we are comfortable with as of gas chromatography or liquid chromatography to increase or decrease the retention time based on in favor to our separation to get a maximum yield. So it gives a wide range of selectivity in both. We can use either gas chromatographic method or liquid chromatography. And then the one more advantage of supercritical fluid is that the ability to use the detectors. It has a wide range of selection of detectors. Here also we can select the detectors of gas chromatography or we can use the detectors which are employed in liquid chromatography, such as FID detectors, UV visible detectors, fluorescent detectors, etc. So we can select a wide range of detectors, universal selective detectors to perform any separation technique, separation mechanism of given solute molecules. Some widely used gas detectors are thermal conductivity detectors, AIM ionization detectors, nitrogen or phosphorus detectors. Some widely used liquid detectors such as refractive index detector, absorption detector, fluorescence detector, conductivity detectors. From these detectors, we can choose any one of the detectors we are comfortable with. So it gives a wide range of selectivity in the selectivity of detectors. We can select any one of them in order to detect the various components present in the solute molecules of in the analytical sample. And depending on which the critical fluid used, it is also possible to use supercritical fluid at low temperatures than gas chromatography. This makes it more useful in separation of thermally unstable compounds. This explains that in gas chromatography, if you decrease the temperature in order to extract any solute molecules, the gas used in the gas chromatography behaves abnormally and the yields are very low. But in supercritical fluid extractions, the temperature can be lowered in order to extract some thermally unstable compounds with a higher yield when compared to gas chromatography. And the stationary phase used in supercritical fluids can be similar to those of liquid chromatography as well as gas chromatography. The stationary phases can be choose either of the liquid chromatography or gas chromatography as our choice. Either packed or open tubular column may be used as a stationary phase or column for the extraction of various solutes, uh, various components of in the present in the analytical samples. So the supercritical fluids have improved yield and the product properties and lower production cost, which makes it more economic and efficient. The supercritical fluids have improved yield when compared to gas and liquid chromatography because it has wide range of selections. We can select anything we want in terms of detectors. We can alter the retention times based on our choice. We can use any kind of column. So, by all these advantages, the supercritical fluid extraction method are more yield provides more yield when compared to other methods. And the supercritical fluid extraction methods are more economic and efficient when compared to even gas and liquid chromatography. So, in supercritical fluid extractions, there are mainly two types of extraction. One is offline extraction and another one is online extraction. In supercritical fluid extraction, we just separate the molecules, various different molecules, components present in the analytical sample, but we cannot identify the components present and we cannot quantify the components present in it. In order to quantify and identify the components present in the supercritical fluids, we have to introduce or subject into various instruments. Coming to online extraction methods, there are many choices to combinations. The supercritical fluid extraction may be combined with gas chromatography in order to quantify and identify the various components. It may be combined with liquid chromatography or it may be combined with supercritical fluid chromatography itself in order to quantify and identify the concentration of different components present in the analytical sample, given analytical sample. So first, let us see the offline extractions. In offline extraction system, offline collection systems are simpler when compared to online method. In this method, the analytes are collected by immersing the restrictor in few millimeters of the solid. Here, the restrictor is nothing but the pressure regulators, which provides the favorable pressurized condition in order to in order to obtain the ideal behavior and ideal separation of by using the supercritical fluids in this method. So, allowing the gaseous supercritical fluid to escape into the atmosphere, analysis have also been collected and absorbed on the silica surface. So, when we introduce the restrictor by immersing a few millimeters into the solvent, when it provides the necessary pressure, when it creates the necessary pressure, the various components present in the sample get absorbed over the silica and separate in order to get separated. The adsorbed analytes are then eluted with small volume of liquid solvent. in order to separate or in order to elute the various components present, we use a small volume of liquid solvents. And then at last, the separated analyze different components from the sample to identify the different components present in the sample and to quantify the sample. We have to subject into the several methods such as optical, electrochemical, or chromatographic methods. These methods, when we subject the separated sample into these methods, it gives the necessary signal and it provides the data and it identifies the different components present in the analytical given analytical sample, and it also helps to quantify how much the concentrations present in the compounds of different compounds. And coming to online method, the effluent from the restrictor of the after depressurization is transformed directly into chromatographic system. In offline systems, we manhandle the sample in between, but in online system, once we introduce the solute into the apparatus, we do not handle the sample in between. But in offline system, after the sample undergoes the separation, we have to handle the sample by eluting after elution. We have to handle the sample by ourselves, and then we have to subject into the several methods such as electrochemical and chromatographic methods. But in online methods, once the sample is introduced into the instrument, we do not have to manhandle the sample in between. Once it has been introduced into the uh, system, it separates and gives, identifies the various components present in the analytical sample, and also quantifies the various components present in the analytical sample. So, in most of the cases, the gas chromatography or supercritical fluid chromatography instrument, although occasionally HPLC system has been used in order to quantify and identify the various components present in the given analytical sample in online extraction method. The main advantages of online system is that the elimination of sample handling between the extraction, as I mentioned earlier. The sample handling between the extraction system is avoided in the online method, and the measurement of the potential for enhanced sensitivity, because more dilution of analytical analyte occurs here in the online method. In offline method, in order to elute the separated components, we have to dilute with some solvent. But in online method, we do not need any dilution. For the dilution of the separated solvent, we can just introduce into the gas chromatography or supercritical fluid chromatography or HPLC method to quantify or identify the various components present in the sample. So these are all the references which I have made in order to present this topic. So let us now discuss some questions related to supercritical fluid extraction. So, what are all the disadvantages of the supercritical fluid extraction? We have discussed earlier all the advantages of supercritical fluid extractions. So, as you all know, every method has its pros and cons. Supercritical fluid extraction method also has some disadvantages. They are the pressure operating conditions are much complex, and it is much more difficult in order to maintain the pressure, required pressure in order to ideal behavior of supercritical fluids. So, and the cleaning of the instrument after the extraction is much more difficult complex, and time consuming in nature. So these are all the some disadvantages that the pumps which are used in supercritical fluid uh, to generate the pressure are much more bulkier and economically costly when compared to other methods. So these are all the some disadvantages of supercritical fluid extraction. And then coming to the next question, how can we extract the limonene using the SCF? Can we extract the limonene using supercritical fluids? Yes, the answer is yes. We can extract the limonene using supercritical fluid. The limonene is nothing but a yellow oil which can be easily separated through the orange peels by using carbon dioxide as supercritical fluids. The carbon dioxide at its supercritical temperature and pressure dissolves the limonene content from the orange peels and can be extracted after the separation, uh, after the performance of separation from the material used. So, coming to the next question, can we extract the polar components using supercritical fluids? The answer is again yes. We can extract the polar components compounds using supercritical fluids. But for extraction of polar compounds, the supercritical fluids are not the best suitable methods. There are other methods in which the polar compounds can be extracted very easily, but in supercritical fluid extraction also the polar components can be extracted by altering the properties of supercritical carbon dioxide. So the carbon dioxide in its supercritical state, supercritical fluid state behaves much more non-polar in nature. It also has some slight polar in nature due to water pole movement. So in order to convert the supercritical carbon dioxide into a polar in nature, we have to bind or combine it with a co-solvent. A co-solvent is a substance which increases the polarity of supercritical carbon dioxide. So by increasing the polarity of carbon dioxide and then using a non-polar stationary phase, we can elute the polar components using supercritical fluid extraction with which follows the similar principle as in RPHPLC. So the polar components, when we use the supercritical fluid, modified supercritical carbon dioxide with co-solvent with increased polarity, and the use of a non-polar uh, stationary phase, we can elute the polar components first at ease. So coming to the next question, so what are the principle of gas chromatography? Is this principle of gas chromatography and supercritical fluid chromatography are the same? No. The principle of gas chromatography is basically that in gas chromatography, the gases are used as a mobile phase. The gases are mainly inert gases are used as mobile phase, which just helps to carry the gas, the solvent molecules into the chromatographic column in order to undergo the separation. But in the supercritical fluid chromatography, supercritical fluids are used as a mobile phase, and it also interact with the molecules, several molecules present in the given analytical sample. And then at last, the supercritical fluid, how the supercritical fluid are useful in food processing. The supercritical fluids are useful in food processing in order to extract several oils. We can use supercritical fluids And in order to extract the fats content in the food, we can use supercritical fluids. And in order to extract many essential oils like vegetable oil or fish oil, we can use supercritical fluids. And in order to extract any flavors, we can use supercritical fluids. So these are all the applications of supercritical fluid in the field of food processing. So at last, the supercritical fluids has the wide range of applications, but does the supercritical fluid has the application in our day-to-day life? The answer is yes. The supercritical fluid are used widely in our day-to-day life. The supercritical carbon dioxide are used in many coffee shops or the coffee bars. The supercritical fluid, carbon dioxide, the supercritical carbon dioxide is used to extract caffeine out of your coffee or tea beverage in many coffee shops in order to decaffeine your coffee or tea. So these are the main applications of carbon dioxide supercritical fluid. So this supercritical fluid, in order to extract the caffeine, it just do not alter any of the taste of your drink, coffee, or it just removes the caffeine content without producing any toxic substances as a byproduct. So, by this property of supercritical fluid, it is widely used in our day-to-day life. So, this is all about the supercritical fluid extractions principle and online and offline extractions. This is all about the topic. Thank you for giving your valuable time.